Hello all, myself Kalpana, Assistant Professor in EEE Department, Marri Laxman Reddy Institute of Technology and Management. Today I am going to explain network theorem. It is a part of electrical circuit analysis 1 for electrical engineering students. So, network theorems. So, we have superposition theorem, Thevenin's theorem, Norton's theorem, and reciprocity theorem and maximum power transfer theorem. So what is the use of these theorems in electrical circuit analysis? Actually, we need to, if we want to calculate current through or voltage across any of the particular element in the circuit, we need to apply network reduction techniques. As part of these network reduction techniques, we have theorems also, so that we can easily calculate the current through or voltage across any of the circuit element. So that is the purpose of network theorems. So today I am going to explain about superposition theorem. So this theorem is called superposition theorem because we superpose or algebraically add the voltage across or current through the branch due to each independent source acting alone to obtain the total current in or voltage across the circuit element. So this theorem is applicable only for linear and bilateral networks. So coming to the superposition theorem statement, superposition theorem statement states that in any linear bilateral network where more than one source is present, the response across any element in the circuit is the sum of the responses obtained from each source considered separately. In contrast, all other sources are replaced by their internal resistances. If the internal resistance is not found, we need to replace it by respective short circuit and open circuit. Short circuit means when the voltage source is there, we are short circuiting the voltage source. If it is a current source is present in the circuit, we are open circuiting the current source. So next, coming to the procedure. So how to apply superposition theorem. So the procedure is, in first step, it is to select among the multiple sources. Means if the circuit is containing two or more sources, so we need to take only one source at a time and calculate the response. Response in the sense voltage or current in particular element. Element in the sense here resistance or inductance. So that is the first step. Next step, we need to consider another source and other source remains inoperative. Again, we need to calculate the response in particular element. Afterwards, we need to add these two responses which as per the statement states in the superposition theorem. So, I will explain by taking one example. So, now consider one circuit which contains two sources. So here we have two sources. One is voltage source, and another one is the current source. So here I am supposed to calculate the current flowing through the 2 ohms resistor by using superposition theorem. So here we have two sources. One is voltage source, that is 10 volt source, and again another one is the 2 ampere source. So first I need to consider only one source is acting in a circuit. So for that, in first step I am considering 10 volt source is present in the circuit. And 2 ampere source, which is the current source, it is not having any internal resistance, so it is open circuited. If the internal resistance is there, we need to replace with the internal resistance. So 2 ampere source is open circuited. So then the circuit becomes this is the circuit. Here it is open circuited. So only 10 volt source is acting in the circuit. So now I am considering the current in 2 amperes, 2 ohm source is 2 ampere source is, let us take it is I1. So I am calculating the current through I1 by taking only 10 volt source. So here by applying KVL to this loop, I am writing the KVL equation here. So that is 10 volts equal to 1 into I1 plus 2 into I1. Why? Because the current is not flowing in the 3 ohms resistor because of it is open circuited. So from this current I1 becomes 10 by 3 amperes. So this is due to 10 volts voltage source. So as per the statement states above, only we are considering one source at a time and other source inoperative. So now I am considering the 2 ampere source is present and 10 volt source, that is voltage source, is short circuited. So then the circuit becomes, so it is short circuited and here we have resistance and again we have 2 amperes, 2 ohms resistor and again here 3 ohms resistor. Here we have a current source, that is 2 amperes. So now because of 2 ampere source, so what is the current in the 2 ohms resistor? So now I am considering this current as I2. So here current, this 2 amperes is dividing here at this node. So here this 2 amperes is dividing by I2 and again I am considering this as some I dash. So here total current, 2 amperes current is dividing by I dash and I2. So for this I am applying the current division rule. So as per, from the current division rule, this current is dividing by 1 ohm resistor and 2 ohms resistor. So from I need to calculate the current in 2 ohms resistor. So by applying the current division rule, total current means 2 amperes current into opposite resistance. Opposite resistance means for 2 ohms resistance, which is the opposite one? 1 ohm resistor is the opposite one. So opposite resistance by total resistance. Total means this 1 ohm and 2 ohms resistor. So we will get 2 by 3 amperes. This is due to 2 amperes current source. So from the statement given in the superposition theorem, the response in any of the element is equal to the algebraic sum of the responses present when we consider the sources separately. So from I have calculated because of the 10 volt source. So what is the response given in 2 ohms resistor is, I have calculated here 10 by 3 amperes, that is I1 is 10 by 3 amperes and due to 2 ampere source, it is I2, that is nothing but 2 by 3 amperes. So I am when we consider the both the sources, means I equal to total current is nothing but I1 plus I2. So we will get 10 by 3 plus 2 by 3. So that is nothing but 4 amperes is the total response due to 2 sources. So that is the superposition theorem. So where it is applicable, means what are the limitations of the superposition theorem. So this theorem is only applicable to linear elements. It is not applicable to the non-linear elements, and also it is applicable only to determine voltage and current only. It is not applicable to the power sources. So application of this superposition requires, and this is the prerequisite, that is 2 or more sources only present in the circuit. So I have taken these from these references, that is Byju's.